Hello, I'm working here on some ideas involving Gaussian curvature. In particular, this video will be focused on something called the second fundamental form. And I'm starting here with a function whose tangent plane is definitely not the same as the UV plane. I've got it diagrammed down here. And it goes, just kind of picked out some weird random things. 0.5 sine u minus 1 squared plus 2 sine u minus 0.4 sine v plus 0.3 plus 0.5 sine v minus 0.5 squared. All right, we've got this plot of u going from -3 to 3. I put in some box ratios and a reduction in the opacity to give this nice transparent thing. And I'll tell you what I'm imagining. I'm imagining like taking a more solid colored surface and just moving it along this thing. And what I want to do is test what's called the second fundamental form, which is actually based on these three letters L, M, and N. I had to put a C in there because, well, because N, capital N, is already used as a mathematical function, so I wanted to make everything look the same. See already there is a problem with the with using this notation because I'm kind of double using some things. Namely, I'm using u as both a variable in this thing and in this thing. Would it fix it if I just plugged evaluate in there? Let's not do the whole thing, just do I'm sorry, ru of 0, 0. See what that does. And yeah, that came out fine. It came out as 100.0897356. So as long as I put an evaluate in there, it seems like maybe that will help. Now I have my L, M, and N. I think it is time to define my second fundamental form. And this is also going to be a function of u and v. Actually, it might be a function of u, comma v, and du and dv. Okay, so this is our second fundamental form. It goes L times du squared plus mc, or times m plus m times du dv plus n times d squared v dv squared. There was something I wanted to do here with the usual form. It actually goes L du squared plus 2m du dv plus n dv squared. Do I trust that though? Actually, you know what? I'd like to. Okay, now what am I going to do with this second fundamental form is what I'd like to kind of do is show this 3D plot of the curve. There's the 3D plot of the curve. And see if I can try to show a rendering of the second fundamental form of the curve at a given point, u comma v. And probably what I'll be doing is just setting du and dv to like a small number. So here, for instance, we've got z of u comma v. Actually, what I want to do is call this BigPlot equals that. And I can just put a semicolon here so it won't show anything. And then SmallPlot is the plot 3D. I think what I want to do with this is actually go ahead and add plus. I want to add z of u comma v to this because otherwise it's going to be 0 in the middle. So I actually have it elevated to the surface by putting a z of u comma v in there. And I'm not really expecting this to work everywhere, but I do kind of expect that in this in the places on the curve where things are rounded, that it will, or that, I mean, that it's pretty close to even with the tangential plane. I think this is going to come out right. And other places where it's definitely not parallel to the tangent plane, it's not going to be correct. That's what I'm expecting. There's going to have to be some kind of correction made where u comma v, where the uv plane is not at all tangent to the curve. Small plot is going to be a function of u comma v. So it's going to have a colon equals. It is going to be the graph of the second fundamental form of u comma v comma du comma dv with, say, du going from, I don't know, negative 0.3 to 0.3, v going from negative 0.3 to 0.3, so that hopefully it will just kind of overlap that graph. I don't think I need box ratios and opacities for the second term as long as I graph this one first. So I'm going to delete that part, because what I'm going to do is use the show command to put them together in the same diagram. So let's try show BigPlot, SmallPlot 2, 1. And it says raw object 1 cannot be used as an iterator. And I think that might refer to the error here, hopefully. All right, and here what do we have? Something quite that does not look in the least bit tangent to the curve at all. So what's the problem? Well, first of all, I probably should mark exactly where the center of that is. It's a little bit hard to tell, but yeah, there's sort of a region where it looks small. Not sure exactly what box it's pushing out. So what I'm going to do is create a graphics object that has a point at the, or I'm going to have 3 points on this thing. One of them is going to be r of u comma v. That's our vector representing the point in the surface that we're in. I'm also going to have another point r of u comma v plus n of u comma v. And that's going to be our normal vector. And a third point that is just like r of u comma v plus n of u comma v, but it's going to be minus. And that will give us 3 points. And then we will also have a line. How did that parentheses get in there? And then we will also have a line. Let's see, where is that? Okay, this bracket goes with point. And wait, how come that isn't? What goes with point? That goes with point? No, that can't go with point. How can there be? That goes with that. This goes with point. They're giving me too much stuff here. They're highlighting too many things. Oh, okay. Right. I need another bracket here. Okay. Point, comma, line. And it's going to be r of u comma v minus the n of u comma v. Just a line to connect the 3 points. 2. Actually, this should also be in brackets 2 r of u comma v plus n of u comma v. And so we're gonna add this normal vector to our plot. U comma v has to be in there in the description because the normal vector is going to be at point u comma v. Okay, so there are some definite issues here because 2 comma 1 is way over there and my normal and my small plot came out way over here. So I'm nowhere near the actual surface. So I need to fix something. What is it that I need to fix? I need to fix something pretty major. I have a couple of suspicions already, but I think it's going to be easier if I turn this into a manipulate command. Mainly, the main suspicion is that we've got it plotting that little graph in the center of the plot near the origin, 0, 0. And so I need to do something to move the thing over to the correct spot. Okay, there's a rendering issue because the thing does not update very quickly. But you can see this curve as I change the values. As I change those values, it seems to be moving. It does seem to be moving to a new center, doesn't it? I'm definitely getting the sense that this line, or the normal, is being mapped correctly. But I'm definitely also getting the sense that u comma v is not. What if I think one thing I'm going to do is shrink this to a 0.1 to 0.1 and make that little surface a little bit more constrained. See what happens to that. Yeah, you can see now that it puts that little patch in a very small area. It looks almost accurate right there, although I can't really tell whether it's accurate or not. Now it comes up and misses. It's so black. It's weird. Okay, let me point out something that I should keep track of. I'm testing a hypothesis that I actually don't believe is true. So if I can't get this to work, in some ways, the conjecture that I have is proven correct, but I do want to get things to the right place. The conjecture I have is basically that I am trying to, get this curve over here to see if it matches this curve, and I think you can already tell it doesn't. But what I would need to do is figure out a way to either move this form over here, move this form and the normal over to here, or to could be a way to do it, or to move this thing over here. And to move this thing over here, so when the program gets second fundamental form with two constants for u and v and du dv as the elements, it gives us a function in terms of du and dv, which is going to draw the element somewhere in here. It actually uses the du and the dv as its actual coordinates. I'm going to try something. I don't know for sure this is going to work, but to shift this to the right, or shift this towards u and shift this towards u and this towards v. doesn't quite feel right, but I'm just replacing all the du's with du minus u, du, and the dv's with dv minus v, and that didn't do much different. It does move this thing around that now though a lot more, but I need to, there's some other way to move it to that point. That's what I need, is to move it to that point. So let's just get rid of those things that I just added. Du minus u, and this should just be du dv, and this should just be dv. And then what? I think what it's time for now is that I try to solve this problem using my own brain and try to find out how the solution to this problem might or might not relate to that second fundamental form. And once I can find out how these two ideas work together, I can make a distinction between them and decide whether the second fundamental form is a good device. It's probably a good device if you know how to use it, but right now I don't see any I don't see anything for it that will help me, that'll really help me see how, because it they make it sound like this is a good description of the curve at that point, but I can't tell. But if you don't know how the variables work together exactly, all you know, maybe maybe um, you could, maybe that curve there is somehow an approximation for this curve where that normal line appears. But unless you know how to convert between the variables, the xy variables and the uv variables, it's not terribly helpful. But so I'll try to make that the subject of my next, well, of what I do next. I don't know whether I'm going to get it in the next video, but just try to make a relationship between the xy variables and the uv variables and see if I can get a curve to, like an approximate curve to follow this curve around. Thanks for watching.